Alright, this is Mark Anderson for Kellogg Community College, and in the second video about rationals, we are going to look specifically at multiplying and dividing rationals. And in the process of doing so, we're going to review excluded values and talk about the different types of factoring that you're going to encounter in this unit. So to begin these 6 problems, we'll start off with a problem that has no binomials in it. It is a problem that can be simplified, but I want to kind of highlight a couple rules first of all, that when you are multiplying fractions, like in the first 3 problems we do today, multiplying fractions is a pretty easy step. The numerator and the denominator, which we can also refer to as the top or bottom of the fraction, are multiplied straight across. So I've said this rhyme before in my classes: multiplying fractions not a problem, top times top, bottom times bottom. That works really well. And another process that students have told me before is like, Mr. Anderson, I've heard about cross-canceling. Can I cross-cancel problems? And the answer is yes, but only if these problems are being multiplied. So we're going to have problems in the future that are going to be divided or added or subtracted or have an equal sign. Cross-canceling is not allowed in that situation. You're only allowed to do it if you have a multiplication problem. So if I look at this problem here, cross-canceling is not only allowed, but it's encouraged. Because if I look at the 60 and the 15, both of those can be divided by 15, leaving me with a 1 and a 4. The 8 and the 24 can both be divided by 8, leaving me with a 1 and a 3. With 1x in the numerator and 2x's in the denominator, that leaves me with 1x in the denominator using our simplification rules for powers of variables. 3 on the top, 2 on the bottom leaves me with 1 on top, and then 2 on the bottom and 3 on the top leaves me with 1 on the top, and 2 on the bottom and 2 on the top leaves me with none, because b squared divided by b squared is 1. So 1 times y times 1 times a and a bunch of other ones is just the product of a, y, and then 4 times 3 times x is 12x. And it behooves me to kind of talk about the excluded values again. And excluded values is when we go back to the original problem, look at the denominators, and see what denominators would have caused us a problem if we plugged in a 0 for those letters. And the letters in the denominator were a, b, x, and y. And those letters, the a, the b, the x, and the y, none of them could be 0, because if I plugged in 0 for any of those, you would get a division of 0 error. And even though in the final problem we may not have some of those in the denominator, since they were in the denominator in the first place, we do have to consider them, because 0 divided by 0 is still undefined. 0 divided by 0 is not 1. So keep that in mind, that our excluded values should be checked at the start of the problem, maybe not at the end like I did there. So let's focus on number 10 and deal with the excluded values right away. So to find our excluded values, it's probably best to factor. So I'm going to factor this binomial here by factoring out of x, which will bring me 2 of my excluded values, that x cannot be equal to 0, and also x cannot be equal to positive 5. If you wish to learn more about excluded values, you may wish to watch the previous video in this series that talks about radicals and simplification. In the second fraction, I'm going to factor this x squared minus 4 as a difference of squares, x plus 2x minus 2. And then I can continue on with my finding excluded values, which is negative 2 and positive 2. Because again, if I set my x minus 2 or my x plus 2 not equal to 0 and solve for x, I would move the 2 to the other side, and that would be x is not equal to negative 2. Well, let's look at the numerator here. The numerator has an easy trinomial factoring. The 2 numbers that multiply to make negative 10 and add to make negative 3 is x minus 5 and x plus 2. Over here, the x plus 10, well, there's nothing to factor out there, but I don't want to forget it either. I've had several classes forget that the x plus 10 was sitting there. So when they got happy about simplifying or canceling in their minds, they left off the fact that there was an x plus 10 in the numerator, and in the denominator what's left is an x and an x minus 2. This is a reminder that you cannot simplify any parts of these at all. You cannot cancel out the x plus 10 and the x as talked about in the previous video. The third example of multiplying these fractions here, deals with some very tricky trinomials. There are many different ways to factor a trinomial, and in terms of many different ways, I've seen 3 different techniques. I've seen an area map, which is a pretty nice way to do it. I've also seen a kind of a flip or switching method that takes probably the most amount of skill but the least amount of time. I kind of settle on this technique where and I'm going to take each of these 4 parts and break them down to show you where I get their answer. And this is a really great review if you're not so good with tricky trinomials here. And a tricky trinomial is something I call with the x squared if that's not a 1. In the previous problem, it was pretty easy to factor something that had a 1 in front, but when you have a 3 in front, you're dealing with many more problems. So let's look at the numerator of the first fraction. I'm going to multiply the 3 times the 3 to get 9. Now I have to find a composite 2 numbers that would multiply to make 9 that would add to make negative 10. In that case, it's going to be negative 9 and negative 1, because negative times negative 1 is 9, and then adding that up would make a negative 10. So this changes my numerator of this problem to be 3x squared minus 9x minus 1x plus 3. Now I use grouping to factor this. I factor out of the first 2 terms a 3x, which gives me an x minus 3. And then I'm going to factor out of these 2 terms a negative 1, which gives me an x minus 3. Using a distribution property, I can now take my 1x minus 3 and write it once, and write my 3x minus 1 once as well. And there's my factorization of this binomial or trinomial here. X minus 3, if you foiled this with 3x minus 1, will give you the original trinomial. Again, I will probably have some videos that I can refer to, and I'll make those probably in the future to go over some of these things I've covered in class. So if this technique of trinomial factoring isn't so great for you, you may want to skip ahead in the video as I get these other 3 done, and you can then look at me simplify this work. Okay, so now I'm looking at this trinomial. 2 times negative 2 is negative 4. I need to think of a number that would make negative 3 with addition that would multiply to make negative 4. That's a pretty easy one to find as well, because negative 4 times 1 is that, and negative 4 plus 1 is that. And now I'm going to go to x squared minus 4x plus 1x minus 2. I would never leave the 1 or the negative 1x in the final answer. I just use this as a kind of a helper there. 2x factored out of the first 2 terms, which gives me x minus 2. And then if I factor a 1 out of this problem, I get an x minus 2. So this is going to be 2x plus 1 and an x minus 2. Okay, so 2x plus 1 and x minus 2. Okay, 2 times negative 3 is negative 6. 2 numbers to multiply to make that and add to make negative 5. That's going to be negative 6 and positive 1. So this makes 2x squared. Instead of writing the middle term as negative 5x, I'm going to write it as negative 6x plus 1x minus 3. All right, factor something out of the first 2 terms, 2x, which gives me an x minus 3 here. Factor a 1 out. It gives me an x minus 3. Lo and behold, here's my factorization. 2x plus 1 and x minus 3. All right, so here it is, 2x plus 1, 1, and then x minus 3. All right, last one to go. Let's see, 2 times negative 6 is negative 12. Ooh, lots of options here to make a negative 1. That's going to be negative 4 and positive 3. So I'm going to rewrite my trinomial as 4-term problem. 2x minus 4x plus 3x minus 6. Factor out of the first 2 terms a 2x, and that leaves me with an x plus, or sorry, not plus, shoot, x minus 2. And then in the other situation, I'm going to factor out a positive 3, and that gives me an x minus 2. So now I have 2x plus 3 and x minus 2. Minus minus? No, x minus 2. There we go. So over here, 2x plus 3, and then an x minus 2. Now, I'm going to find my excluded values by looking at the denominator only, and in my denominator, my x cannot be equal to, and I'll take this first one. If 2x plus 1 cannot be equal to 0, I would move the 1 over, making it negative 1, and divide by 2. So that means if I plug a negative 1/2 into this parenthesis, I get a division of 0 error. The next problem is a little bit easier because I can mentally think 3 minus 3 makes 0. Over here, this is going to be 2x plus 3 cannot be equal to 0, so I am going to move the 3 over so it makes negative 3 and divide by 2. So 2 times negative 3/2 would give me a negative 3, and that would give me the 0 problem there. And then finally, 2 cannot be one of my numbers because if I plug 2 into this problem, then I'll get another division of 0 error. And now watch the simplification. So the 2x plus 1s, they simplify to make 1. X minus 3 simplify to make 1. X minus 2 simplify to make 1. My final answer with these 4 exclusions for values of x is 3x minus 1 divided by 2x plus 3. And that is problem number 11. Took a lot of time because of all the tricky trinomials there, but it's a good review for that problem itself. Our final 3 problems are going to be, instead of multiplying fractions, top times top, bottom times bottom, we're going to divide fractions. But the division of fractions, again, it would be really nice if we turn these into multiplication problems, and we can. The pattern for using multiplication problems is you skip the first fraction, flip the second fraction, and then multiply. So skip, flip, multiply, which means that you'll take this problem, and instead of dividing, you're going to multiply, and then you can flip this on its head. You're just going to spin this around its division bar. So now the numerator is 100x to the 4th, y squared, and the denominator is 27x cubed y squared. And that's what's great about that is now we can look at this as being a problem that we can multiply, cross-multiply, cross-cancel. I'm sorry, I said cross-multiply. I mean cross-cancel, like we did at the top of the worksheet. So let's continue the process of cross-canceling, or simplification there. 25 and 100 goes in there 4 times. 9 goes into 18 and 27 twice and 3 times respectively. Now what you can cross cancel this, but if you just look straight down, you can see that I'm going to have 1x left here in the denominator and 2 y's left here in the numerator. And over here I'm going to have 1x in the numerator here, and I'm going to have these y's fully simplify because they're exact matches there. And also now I look cross to see if there's any cancellation there, and I see the 1x down below and the 1x up above. Get rid of that, get rid of that. So that leaves me with 2y squared times 4, or 8y squared, and then in the denominator 1 times 3, which makes 3. And don't forget your excluded values. We had x's and y's in the denominator at the start of the problem. X's and y's both can't be 0. But this brings up a good point, because am I checking before or after the multiplication? Or excuse me, before or after the skip, flip, multiply step? You would skip, flip, multiply first, like you would then move this up and then move this down and then check for your excluded values. Because as you do your multiplication, you cannot have a division of 0 in that situation. So we're going to do our factorization right now of this bottom part here, and the 2 numbers that multiply to make the negative 13 and add to make the 42 is x minus 7 and x plus 6. Or sorry, minus 6. Sorry, so I'll do a plus negative just so I don't have to erase that or redo the video. So x minus 7 and x plus negative 6. Now this numerator is now going to get put into the denominator, so this is going to be 2 numbers to multiply to make 20 and add to make negative 9. That's x minus 5 and x minus 4. So my excluded values are going to be x cannot be equal to 7, 6, 5, and 4. Because if I plug a 7, 6, 5, or 4, then I get a division of 0 error. Now I'm going to look at the factorization of this x squared minus 11x plus 28. That's going to be x minus 7, and then x plus 4, or excuse me, minus 4. And again, to do these simple ones, you look at 2 numbers to multiply to make the third term and add to make the second. And now let's look at this denominator, which is now in the numerator because of the multiplication, and that's going to be 2 numbers to multiply to make negative 30. X minus, let's see, that's going to be 6 and 5, so x minus 5, and then x plus 6. All right, so now we're going to do we're going to kind of get rid of that there, so we're not looking at it. We're going to do some simplification or cancellation, And those are the matches. The x minus 5s are above each other, x minus 4s, x minus 7. And now what I have is an x plus 6 in the numerator, and in the denominator an x plus negative 6 or x minus 6. This cannot be further simplified, and it can't be further simplified because you can't just pick an x or a 6 out. And that was discussed in a previous video. So for our final problem here today, let's look at number 14. Tricky trinomials, so let's go and have some fun with these. Let's go and do the numerator over here. So this is going to be 2 times negative 3, which is negative 6. Two numbers to make negative 6 and add to make negative 5. That's going to be, or positive 5, excuse me. Got to be careful about this one because you might be tempted to go 2 and 3 to make 5, but 2 and 3 does make 5 if they're both the same positive or negative number, but this is a minus 6. So what we need to have is a positive 6 and a negative 1. This is got to be careful with this one. It's very easy to screw this problem up. So 2x squared plus 6x minus x minus 3. And so now we're doing some factoring. Factor out the 2x to make x plus 3. Factor out a negative 1 out of this binomial for x plus 3. And that gives me, in the numerator, 2x minus 1 and x plus 3. And you can always FOIL to check your answer. Now we're going to turn this into a multiplication and move this upstairs. So that's going to be an x minus 5. Down here in the denominator, this is an easy trinomial, x minus 5, x plus 3, to make a multiplication of negative 15 and add to make negative 2. But what about this here? Okay, so let's try this one out. 2 times 2 is 4. We're going to look at two numbers to make 4 and add to make negative 5. That's negative 4 and negative 1. So we're going to rewrite the trinomial as 2x squared minus 4x minus 1x plus 2. So factor out a 2x here, and this gives me gives me x minus 2. Got a little excited there. Inside the parenthesis, x minus 2. And then we factor out a negative 1, which gives me x minus 2 over here. So my final factorization is 2x minus 1 and x minus 2. I should probably have that over here too, just so there's a little symmetry in that page. And so now this numerator is now taken into the denominator of 2x minus 1 and x minus 2. And before we start canceling or simplifying, let's go through our excluded values. X cannot be equal to 5 from this number. X cannot be equal to negative 3 from this number, right there. 2x minus 1 cannot be equal to 0. So if we move the 1 and divide by 2, 1/2 is a danger number. And then 2 is another danger number. So let's see what simplifies. Let's see, this divided by this makes 1. X minus 5 divided by x minus 5 makes 1. X plus 3 divided by x plus 3 makes 1. So it looks like all we have left is x minus 2, but it's in the denominator. And since it's in the denominator, you got to put that under 1. And that will satisfy the problem with all of those excluded values. Well, thank you for watching the video. I hope this has helped out. I will, again, send me a KCC email if you've got any questions. Thank you.